Suppose you're given two types of fruits, kiwi and apple, right here. And also I give you their features, like how sweet they are and what is their weight. So let's say this is the data given to you right here. This is just a few values I just put out there. I just made up these numbers. And now you're given a new fruit, this one right here. And what's given to you, it's its sweetness and its weight. So you know how much it weighs and you know also how sweet it is. In other words, this is known to you, this number is known to you, and this number is known to you. And your task is to determine what type this fruit is. Is it an apple or is it a kiwi? So these types of questions are answered by using tools from machine learning. One of the tools that is used is K nearest neighbor, KNN. So this session is about KNN. So the idea of K nearest neighbor is very simple. Let's say you're given a test point X. Let's say this one right here. So what you do, you find K nearest neighbor. K, by the way, would be given to you. And what you do is that you assign this point the color or the label that is the most common among its K neighbors. So let's understand this through two examples. Let's say my K equal to 5. In other words, you find 5 nearest neighbor around this point right here. And let's say my 5 nearest neighbors are present inside this circle right here. I'll just draw this little circle just to make it a little clear. And you can see that there are three red points and two green ones. So majority of them are red. So we are going to assign this point as red. Now let's look at this example. In this case, my k is equal to 9. So you find 9 nearest neighbors. So these are my 9 nearest neighbor right here, from here all the way in this circle. And among these 9 points, 4 of them are red. You can count one, two, three, 4. And 5 of them are green. This one, 2, 3, 4, 5. So the majority of the points are green. That means this point is going to be assigned a green label. Now let's look at the algorithm for k nearest neighbor. It's very simple. Your input would be given to you as a data and your k. K would be your nearest neighbor, like how many k nearest neighbor do you want. Your output is going to be the predicted class. So the step number one, you load your data. So I'm starting with this simple example. In this case, I have 6 training data. You can see that 1, 2, 3, 4, 5, 6. This is my 6 training data. This right here is my test data point. And the labels on the data are green and red. And you can see that each one of them have a green and red. Now, step number 2, now take your test data point, which is this right here, and calculate the distance of this test data point with all the points in your training set. So in this case, I'm calculating all the distance. As you can see, the distance from this test data set from this point is 1, for this one is 7, for this one is 4, and I do it for all of them. So the distance are shown next to the arrow for all the training data point. In this case, there are only 6 of them. And then you sort these distances in ascending order. So I print these distances over here: 1, 3, 4, 5, 7, 10. This is the smallest and this is the largest. Now, since you're looking at 3 neighbors nearest neighbor, in other words, your k equal to 3, so you find among these 3 neighbors, what is your majority? So let's look at my 3. In this case, these are my 3 right here. So this is my 1, the distance is 1, the distance is 3, and the distance is 4. This is green, green, red. There are 2 greens and 1 red. So that means my majority is green. So this test data set would be assigned a green color. Now let's look at some of the dataset characteristics that is suitable for your KNN. The first one is that your dataset should be small to medium sized. And the reason is this: your KNN is a lazy learner. In other words, it does not train a model, but stores the whole dataset and it makes a prediction at the query time. Since it's storing the whole dataset, that's why you need small to medium sized dataset. And it works best when your dataset is not very large, say typically less than 100,000 samples. Why is that? Because when your large data set, it will make your KNN slow because it needs to compute distances for every new prediction. Let's understand this through an example. So in this picture, you can see, so you have this test data point right here. In this case, you can see there's a 1, 2, 3, 4. There are only 4 training data points right here. So in this case, you only have to calculate the distance of this and this and this and this, only 4 points. In this particular scenario, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 data points. So in this case, you have to calculate this distance, this, all the way up to 10 different points. So in this case, your computation is more. So the more data points you have, the more distances you have to calculate for each test data point. Now, KNN is suitable when you have fewer features. In other words, low dimensional data. And the low dimensional data in this case would be less than, say, 50 dimension. And why is that? Because as the number of dimensions in your data increases, you have something called curse of dimensionality. And that makes your Euclidean distance less effective. Let's understand this through this example. In this case, I have a three-dimensional data, and I have to find the distance between this point and this point. And let's say this is my x data and this is my y. So my Euclidean distance would be this right here. In this case, there are only three features. So Euclidean distance, you can see, is easy. In this particular case, I have 100 dimension data. And so this is my x right here, and this is my data point, which is y. In this case, when you calculate your Euclidean distance, you'll be doing for each one of these features. And because your number of features is getting higher and higher, your computation is also increasing, and also due to the curse of dimensionality, your Euclidean distance is becoming less effective because of this high dimension. Now your KNN, it is sensitive to scale, and that's because it's using distance, and distance it changes if one feature dominates. So in order to avoid this problem, you normalize or standardize your data. You can use either min-max or standard scaler. So let's understand this through an example. Suppose you have a data that has three features: age, work hours, and income. Now here, my age and work hours, these are your low range numbers. So in a company, let's say this is the data for a company, your age can be anywhere between 20 to let's say 80. And your your work hours can be anywhere between 0 to let's say 12 hours. And your income, on the other hand, this is a high range number. So suppose you have two employees, employee X and employee Y. And employee X, his age is 21, his work hours is 8, let's say. And this is his income. Employee Y, his age, his work hours, and his income is given by these numbers right here. And you can see your incomes are big over here. And suppose we use Euclidean distance to calculate the distance between employee X and employee Y. And I'm using the formula right here. So in this case, you can see that 25 square, this number, it comes from age. This 4 square, it comes from your work hours. And this right here, it comes from income. And you can see your income number, it is dominating because of the big size of this number. These two numbers are very small compared with this number. So in this particular scenario, your income feature is going to dominate, whereas your age feature and your work hour feature is not going to be dominating. So in order to avoid these types of problem, we scale our data. We put all the numbers between a certain range. Let's say it's between -1 to +1. All your age, work hours, and income, put them all in this range. So this way, no one feature will dominate the other feature. Now in your KNN, your data set, it should have balanced classes when you're dealing with classification problems. Why is that? Well, if your one class is overrepresented, in other words, it is dominating, then your majority voting is going to lead to a biased prediction. Your prediction is not going to be reliable. Let's understand this through an example. In this case, you can see that your red is dominating. You have more red labeled data points, and you only have few green labeled points, only 4 of them. So if you take this point right here, and let's say your k equal to 7. So in this case, with according to the 7 nearest neighbor, 1, 2, 3, 4, 5. 5 of them are red and only 2 are green. So in this case, this point is going to be assigned red because your red is dominating, not because that red is closer, Maybe this point should have been classified as green, but because your majority of the points are red, it's very likely that this point and any other point are going to be classified as red. Now, KNN, it works best when you do not have many outliers. If you have many outliers and your test data point is near these outliers, then your KNN is going to give you wrong classification. So let's understand this through an example. In the first figure right here, we can see that the point, this point right here, it should be green because it is next to the green right here. And now I add 4 outlier points, 1, 2, 3, 4. And suppose your k equal to 5 over here. So in this case, 4 are red and only 1 is green. So this point right here is going to be classified as red, not as green, because of the presence of these outliers. Now your KNN, it works best when you have numerical data. For example, let's say your data could be age, salary, height. These could be your features. So let's understand this through this example right here. So here I have to determine what is the value of this point. What is the feature value of this point? And in this case, let's say my k equal to 3. So you find 3 nearest neighbor, and these are my 3 nearest neighbor, 1, 2, and 3. So you take the average or the mean of each one of them. Let's say I'm dealing with the mean. So in this case, the average would be 40 plus 50 plus 70, which is this right here, and you divide by 3. You do the same thing with the next one, 5 plus 9 plus 8, which is right here, and you divide by 3. And the same thing with the other last feature, which is 7 plus 1 plus 2 divided by 3. And this will give you the feature value of this point right here. It can also handle categorical data, but for that you would need encoding. For example, you can use one hot encoding. Now your KNN, it works pretty well when your decision boundaries are complex and non-linear. And why is that? That's because your KNN, it captures pattern in the data and makes no assumption that your decision boundary is fixed. Now let's understand this through an example. Let's look at this first figure right here. Here, I can draw a linear decision boundary easily right here. And this linear decision boundary, it separates your red points or your red classes from your green classes. And this point right here, this point falls on the red classes side. So this point would be classified as a red. Now let's look at this example right here, second figure. Here I cannot draw a linear decision boundary like this that was separating your red classes from your green classes. And here your KNN can help. Here your KNN is going to classify this point as green if you have more number of green points. Let's say in this case you find your k nearest neighbor, and in this case your k nearest neighbor comes out to be 3 green points and 2 red points. So in this case it's going to classify this as green. Now let's look at some few applications of KNN. So one of the application would be filling in missing values. So here you can use the neighbor values to fill the missing ones. Here you can use either the mean or the median of your neighbors. So let's say you are using k equal to 3 and you want to use the mean value. So here, this is my test data point right here, and I want to find the value of this. So in this case, let's say my 3 neighbor are these ones right here, 1 comma 2, 2 comma 4, 1 comma 7. These are the values of the features of his 3 neighbors. Then using the mean, your mean value of your test data point, which is this right here, this would be equal to your 1 plus 2 plus 1, which is right here, divide by 3, and then you do the second one, which is 2, this 2 right here, plus 4 plus 7. 2 plus 4 plus 7 divided by 3. And this answer will give you the mean value of the features of this test data point right here. Likewise, you can also do that with the categorical features. In this case, instead of using the mean or median, you use the mode. In other words, you use the most common category. Another application of your KNN would be recommendation systems. So KNN is widely used in your item-based or user-based collaborative filtering. So for example, your Netflix, it actually finds and it recommends movie based on the nearest similar users, people who are very similar to your interest. Same thing with Amazon. They actually recommend product based on the similar shopping pattern that you exhibit compared with the other ones. Then you also have medical diagnosis and healthcare analytics. This can actually help you classify patient based on symptom similarity. So you can predict whether a tumor is benign or malignant. You can even diagnose disease by comparing patient records.